Good afternoon, all. We are taking lecture on electronic product design system, electronic product design. In that, up to this covered topic is passive components are there, different electrical equipments are there, their functioning, their ratings we are studying. In today's lecture, we are going to study active devices for controlling power. In that, we have to study mechanical relays their working principle, parameters, ratings, applications with example, testing of relays. So after that, next type is solid state relay is there. In that, we have to study magnetic or optical isolation, ratings and specification of input and output, their characteristics, now we move further in detail for each and every point. Different types of relays and their working principles we have to study. But before study the types of relay, we have to know the concept what is relay is there, who is invented, where is initiated and all. Now, history of relay is the development of relay was initiated in the period 1809 as a part of the intention of the electromechanical telegraph. The electrolytic relay was found by Simul in the year 1809. Thereafter, this invention was asserted by the scientist Henry in 1835 so as to make an improvised version of the telegraph and later development this in the year 1831, whereas in 1835 Davy absolutely discovered the relay, but the original patent rights were given by Simile in the year 1840 for the initial invention of the electric relay. The approach of this device appeared the same as a digital amplifier, thus replicating the telegraph signal and allowing for longer distance propagation. And this article gives a clear explanation of knowing what a relay is, different types of relays, working, and many other related concepts are there. Clear? This was the history. Then what is actually the relay? Relay are general employed where it is required Relay are generally employed where it is required to regulate a circuit through an individual minimal power signal, or used where multiple circuits need to be regulated through a single signal. The initial utilization of relay was in the extended length of telegraph circuit like signal repeaters as they invigorate the wave that is received and transmitted to other circuits. The major implementation of relay was in telephone exchange and the initial version of computers. Relay are the primary protection as well as switching device. Switching means to make on and off connection or open or close the circuit. In most of the control processes or equipment, all the relays respond to one or more electrical quantities like voltage or current such that they open or close the contact or circuits. The relay is a switching device as it works to isolate or change the state of an electric circuit from one state to another as the relay makes sure the protection of the circuit to not let any damage to take place. Every relay comprises of three crucial components and those are calculated, comparing and controlling components. The calculated components known the variation in the actual measurement, and the comparing components evaluates the actual amount with that of pre-chosen relay, and the controlling component handles quick variation in the measured capacity like the closing of the current functional circuit. Clear. In short, relay is a switching device and it works to isolate or change the state of electric circuit. Means if circuit is off, after connection circuit will get on. After that off, on, that is switching is there. Relay you can use as a switch also. Clear. Which are the three crucial components and those which are calculated, compare and controlling the components. Variation in the actual measurement and comparing components evaluates the actual amount with that of pre-chosen relay. Reclosing relay are used to connect various components and devices within the system network, such as synchronizing process and to restore the various devices soon after any electrical fault vanished. Okay, क्या है? Reclosing relays are used to connect various components and devices within the system network synchronizing process and to restore the various devices soon after any electrical fault vanish. Clear. And then to connect transformers and feeders to line network. After after connection, okay, transformers and feeders to network line are connected. Okay, regulating relays are the switches that contact such that voltage boost up as in the case of tap changing transformers. Auxiliary contacts are used in circuit breakers and other protective equipment. For contact multiplication, monitoring relays monitor the system condition such as the direction of power and accordingly generates the alarm. These are called directional relays. Which relays are called directional relays? Okay, what happened in that? Auxiliary contacts are used in circuit breakers and other protective equipment for contact multiplication. Monitoring relays monitor the system condition such as the direction of power and accordingly generates the alarm. These are also called directional relay. The general kind of relay make use of electromagnet so as to perform opening and closing of contacts, whereas in the other type of approaches, like in the solid state type of relay, they use semiconductor properties for controlling purposes without depending on the movable components. Relay have relay those have calibrated properties and in some cases various functioning coils are employed to safeguard electric circuit system from overload current. In the current day power system, these operations are accomplished by digital devices where those are called protective types of relays. Protective types of relay calculate the overload current, right? Current day power system. These are the solid state relays. Yeah? The picture. See that diagram. This is the solid state relay which we have to study after studying of DPDT and DPTR. Okay. Different types of relays are there depending on the operating principle and structural features. Relays are of different types, such as electromagnetic relays, thermal relays, power varied relays, multidimensional relays, and so on, with varied ratings, size, and applications. Every mm, relay have their specification, their rating, their working principle, and their own application. According to application and our requirement, we choose our relay. Classification of the types of relay depends on the function for which they are used, right? Some of the categories include protective, reclosing, regulating, auxiliarity, are monitoring relays. Protective relays continuously monitor these parameters: voltage, current, and power. And if these parameters violate set limit, they generate an alarm or isolate that particular circuit. What protective relay do? They continuously monitor the voltage, current, and power, and if this parameter violates set limit, they generate the alarm or isolate that particular circuit. These types of relay are used to protect equipment like motors, generators, and transformers, and so on. Where protective relays are used, it is used in motors, generators, and transformers to protect the circuit. Clear? This is the image for different types of relay, but it's not so clear. I will make it large one. Their shape, their size, their width are different for everyone. Clear? Different types of relay. In general, relay classification depends on the electric capacity which is activated by current, power, voltage, and many other quantities. Classification is based on the mechanical capacity activated by the speed of gas or liquid outflow pressure, whereas based on thermal capacity activated by heating power, and the other quantities are acoustical, optical, and other. Clear? For classification of relay, we have to consider the electric capacity, which is activated by current, power, voltage. Clear? Thermal, power, outflow, pressure, gas, speed. For mechanical capacity, these are the quantities which we have to consider while classification. In our syllabus, there is a mechanical type of relay is there. Na? The, these relays are constructed with electrical, mechanical, and magnetic components, which I told you, and have operating coils and mechanical contacts. Therefore, when the coil gets activated by the supply system, these mechanical contacts get opened or closed. The type of supply can be AC or DC is there. First type is SPDT. S stands for single, P stands for pole, D for double, T for throw. Single pole double throw relay. General purpose single pole double throw relay. In this, a single pole double throw relay connects one input circuit to one of the two outputs. Clear? One input is there, two outputs is there. Okay, therefore it is called as single pole double throw. Connects one point circuit to one of the two outputs. These relays is also called as change over relay. Through the single pole double throw has two output positions. It may consist of more than two throws depends on the configuration and requirement of the application. The Dptr relays we use in our device are designed for an exceptionally long life with over 1 crore operational cycles when used within electrical specification. We use Panasonic LAIS for our 5 ampere controller and Omron for our 10 ampere controllers. We have a 20 years track record with these relays and we are confident they can be used in most switching applications with excellent reliability. General purpose relays are not ideally suited for low power switching applications. So please be sure to choose single relay working with low power signals such as audio, video, and telecommunication. Clear general purpose relays are not ideally for suited to low voltage high power. Okay, Amron, NIIS, Panasonic, these are the companies which manufacture the relays or controllers for low power signal, audio, video, and telecommunication application. We use low power. Okay, this is the DPDT black color picture is there. This is a single pole double dual relay. Here is the circuit diagram for this. See here, figure 1 and figure 2 is there. Hmm? This is the T2 connection 1 and T2 connection 2. That is the two outputs are there. Two equipment can be used. Okay, one is off, one second is on, second is off, one is on. Like that we can switch their functioning between fan 1 and fan 2 using DPTP. Clear? In first figure 1 and figure 2, what happened there? We will discuss the working principle of the SPDT means single pole double throw relay. The single foldable throw Spdd relay is quite useful in certain applications because of its internal configuration. It has one common terminal and two contacts in different configuration. One can be normally closed and another one is open, or it can be normally open and the other one closed. So basically you can see the DPTT delay as a way of switching between two circuits. When there is no voltage applied to the coil of one circuit, receives current, the other one does not, and when the coil gets immersed, the opposite it happening with a sparrow ampere SPDT. Here is two circuits, right? Two output terminals there, 1 and 2 is there. In first figure, when we apply current, it is connected to 1. That is fan 1 is on, that time fan 2 is off. Clear? In second circuit, when we apply current to the coil, then second case is there. That time second fan is connected, 1 is off. Means we can use DPTT as a switching circuit between 1 and 2 applications. I think everybody got the concept is there. What is the working principle? Uses used in all part numbers that contains 5 including DPTT variation. This is general purpose relay ideal for power switching applications where DPTT sorry, this part is not for SPDT, it is from DPDT, which we'll study after this session. I will remove it from here and place it to your right place. The datasheet is Amron. See here, Amron company SPDT is there, single port, double throw is there in this relay. Okay, here is the SPDT uses. Okay. used in all part numbers that contains 10. This is a general purpose relay ideal for power switching. DPDT also used for the power switching, and SPDT is also used in power switching with a very warranty rating of 10 ampere or 24 DC or 10 ampere at 250 volt AC or DC power is there. This relay should not be used for low power signal switching applications as the contacts on this relay are optimized for power applications. Low power signals such as audio will appear to the faulty if this relay is chosen. Clear? Now is DPDT. Double pole, double throw. In SPDT, there is single pole, that is one input is there, and double throw means two outputs are there. Here, double pole, double throw means two inputs are there, two outputs are there. Clear? DPDT stands for double pole, double throw relay. Relay is an electromagnetic device used to separate two circuits electrically and contact them magnetically. They are often used to interface an electric circuit which works at a low voltage to the electrical circuit which works at a high voltage. Relays are available in different configuration of operating voltages like 6 volt, 9 volt, 12 volt, 24 volt. Here there are two sections, input and output. Input section consists of coil and two inputs which are connected to the ground and the input signal. The output section consists of contactors which connect or disconnect manually. The output section consists of 6 connectors with 2 sets. Each set has 3 changeover contacts, normally open, normally closed, and common contact is there. Clear? When no supply is given in the common is connected to not connect. When the operating voltage is applied, relay coil gets immersed and common changes contact to normally open. When not supply is not there in common pin, then connection is normally closed. Okay. When operating voltage is applied, then it goes to change to normally open. Clear? Dptr relays are common in many of our products as they consist of two SPDT switches that active simultaneously. This allows the switching of two completely separate signals used in single relay. DPDT relays are popular for signal switching applications such as audio, telecommunication, and other types of low power switches. Below you will find the DPDT relay are used in our controllers. Which are controllers? Microcontrollers are there now. In that also DPDT is used. Okay. DPDT relay can be used to power where one device applications or another, while SPDT relay can only switch the output circuit between on and off state. The DPDT relay can also be used to change the polarity at the terminal of the device connected at output. Clear? For example, to drive a DC motor in both clockwise and anti-clockwise direction, following connections can be done. Pin 2 and 7 can be provided with VCC 9 volt for motor and ground, respectively. The first motor terminal can be connected to pin 3 and 4 while the other terminal to pin 5 and 6. In case no input signal is given, motor would rotate in one direction, say clockwise, depending upon the connection of its terminal. When an input signal is provided, the contactor changes its position, resulting in anti-clockwise direction. Clear? DPDT wire is used to change the direction, like motor is flow. Motor is moving clockwise or anti-clockwise. If there is no signal, it can move in clockwise. When we apply signal, then it switch to the anti-clockwise like that. This is the example of working principle. To understand the working principle, this is the DPTR. Okay. Uses, used in all part numbers that contains 5 including DPDT variants. Okay. General purpose relay added for power switching applications with a warranty rating of 5 ampere to 24 with DC or AC. This relay should not be used for low power signal switching applications. It is used in part number of contains 1 dpt. This is a small dpt signal relay useful for telecommunication. Relay 1 ampere dpt is an figure which is used in telecommunication switching applications. Warranty rating is 1 ampere at 12 volt DC. And here is 3 ampere used in all these. This this is this relay 3 ampere DPT used in all part numbers that contains 3 DPT. This is signal relay useful for telecommunications, audio and other low power signal applications. Warranty rating is 3 ampere at 24 volt DC. Okay. This is the 5A DPDT used in all part numbers that contains 5 DPDT. This is a single relay useful for telecommunication, high power audio, and other high power signal switching applications. Warranty rating is 5 ampere at 24 volt DC. Clear everybody? You got the concept of Spdd and Dpdt. I think it is okay. We study the working principle, ratings, uses, clear of the relays. Now second type or next is second type of mechanical relay is high power relay. Clear. High power relay. If you need to switch high power loads, we have controllers with a proven track record of reliability. We offer three variations depending on your need up to 30 amperes. High power, it's very high power because in the PDT there is a voltage range is 9 volt to 5 volt to 24 DC or AC volt. Here is voltage range is very large. Okay, 30 ampere current is very large amount of current. If you need to switch high power loads, they have controllers with a proven track record of reliability. We offer three variations depending on your need up to 30 amperes. These relays are ideal for switching lights, motor, pumps, valves, and other high power loads when used with induction separation capacitors. Clear high power relays, there is ampere range is up to 30 ampere. This much amount of power relays is used in switching lights, motor, pumps, valves, and other high power load when used with induction separation capacitors are there. Okay, this is the diagram. Look at here. Thailand NAIS is a company which manufacture it for high power. See here, relay with 20 ampere HP SPDT is there. This relay has a contact rating of 20 ampere between common and normally open and 10 ampere between common and normally closed. Used in all part numbers that contains high power. Only high power application is here. Here is 20 ampere SPDT used in all part where that contain 20. This is a 20 ampere relay with a 20 ampere contact rating. This relay is the SPDT variant and is commonly used in high power switching applications. Okay. Now, working principle of high voltage DC relay. What happen in working high voltage DC relay? When the electric current passes through the relay, the electromagnet establishes a strong magnetic field. The field pulls the armature into the copper coil, creating an electrical arc. Okay, then the electrical current flow into the device in which the relay is mounted. What happens when the electric current passes through the relay? The electromagnet establishes a strong magnetic field. That time, what do electromagnet establish the strong magnetic field? The field pulls the armature into the copper coil, creating an electrical arc. Then the electrical current flow into the device in which the relay is mounted. When there is no current flow, the sparing pushes the armature, breaking the connections, and switch perform the primary role of high voltage DC relay by continuously turning the current on and off. When electric current passes through the relay, the electromagnet establishes strong magnetic field. This field pulls the armature into the copper coil, create an electric arc. Okay, then electrical current flow into the device in which the relay is mounted. Then there is no current flow. The sparing pushes the armature, breaking the connection. The switch performs the primary role of high voltage DC by continuously turning the current on and off. This is the working principle of high voltage DC relay. Application of hands-on high voltage DC relays, electrical vehicles, voltaic, wind power system, energy storage system such as CPU, EV-DC battery charging station, lighting, the technology used. Which technology used? We use two main technologies for our hermetically settled high voltage DC relay. These are ceramic and epoxy. The ceramic high voltage DC relay are filled with hydrogen, whereas epoxy is filled with nitrogen gas. We use these two technologies to eradicate extreme relay discharge when the arc forms. It can never extinguish on its own. The continued arcing The continued arcing means damage to the contact. To extinguish arcing, we adopted a gas filling technique. The gas required for this purpose must be very active and have a suitable molecular structure. The hydrogen gas passes all above characteristics, hence it is used in ceramic. However, owing to the small molecular weight of hydrogen, epoxy cannot properly seal it. That's why nitrogen is preferred for epoxy settled DC relay. For example of ceramic settled high voltage relay include EVH 400, EVH 300, EVH 250. These three examples for the ceramic sealed high voltage DC relay. And for epoxy sealed high voltage DC relay, example is EVQ10, EVQ30 and EVQ50 is there. Okay. Which factors the up to this we study the types of relay of mechanical type. Okay, in that we study working principle, their uses, rating, which value should be there for current and voltage. Now, factor to consider when looking for high voltage. High voltage relay. When we have to purchase the high voltage DC relay, which factors or which quantities must be considered? We see this one by one. If you are looking for high voltage DC relay, you should know that it's not on one size fit all. Different high voltages DC relays have different uses and needs. Ensure you know exactly what you're looking for to avoid inconvenience. Generally consider the following factors before buying your high voltage DC relay. First is reliability, second is safety, third one is compactness, fourth one is lightweight, fifth one is high voltage cutoff, sixth one is current rating of the load, seventh is voltage rating of the load, eighth is the type of load, ninth is latching operation, and 10 one is compatibility. We see these uh, fac- factors one by one. One is reliability. They have good working characteristics and low failure that under all operating conditions. They have very large contact surface which induces the current interruption caused by lost contact. They have quick operation characteristics which reduces sparking when the switch is operated. Reduced sparking helps to reduce wear and tear, thereby minimizing the operation cost and increasing the lifespan of the relay. Clear? Second one is safety. Safety is paramount in the operation of all electrical components. DC relay are designed with an enclosure made of insulating material such as bakelite nylon and the thermosetting plastic to insulate and protect the contact that the machine operators. Safety is therefore ensured due to inherent safety design. Our high voltage DC relays are very suitable and can be used even in harsh environments. They can operate under extreme temperature between minus 400 degrees Celsius and 85 degrees Celsius. Compactness. Modern design of high voltage DC relays are more robust and efficient, and individual compact are components are closely packed, hence reducing the overall cost of the relay, making them chapter. Lightweight is you lightweight. Your high voltage DC relay should be small in size and does not produce noise during current transmission or switching. High voltage cutoff DC sub relay come in many forms with varying capabilities and features. They range from having the breaking current of several amperes to thousands of amperes. This makes them applicable in almost all electrical circuits, depend with the load requirement of the circuit. Current rating of the load. The current rating of the load determines the size of the relay to be selected since different loads have different ratings. Small loads will go with small rated relays, while large loads need high rated relays. Any attempt to violate these rules will lower the efficiency of the relay or damage the relay completely. 7 is voltage rating of the load. The higher the voltage, the higher the sparking. Each high voltage DC relay should be operated and its designed voltage to avoid damage. Our relay can switch high voltage ranging from 12 volt to 500 volt and current from 10 ampere to 600 ampere. The type of load. Three-phase relays should be connected to three-phase loads while single-phase relays to single-phase load. Latching operation. A relay with high latching speed is good because it minimizes sparking and reduces wear and tear of the contact surfaces. Then is compatibility. The relay should be compatible with other electrical components in the circuit for their maximum performance. These components include the power control system like mechanical interlock, bus bars, thermal overload relay, and motor protection circuit and breakers are there. Clear advantages of high voltage DC relay. They don't have hysteresis losses and therefore no power loss associated with their operation. Hysteresis loss is caused by alternating current as it alternates between the positive and negative maximum through zero line. Have high voltage cutoff and high current cutoff making them suitable for all industrial and domestic purposes. Enable the operators to control a remote and locate. Enable the operator to control a remote located machines without necessarily going near the machine. They are not affected by high temperature, hence suited for industrial applications and in place where mechanics experience high temperature during the this one. Next is specialty relay. We manufacture specialty relay controllers for many companies. So if you don't find exactly what you are looking for, we can make it for you. We are also able to manufacture controllers, relays. This is specialty relay as per our need. Next is solid state relay is an solid-state relay is an electronic switching device that switches on or off when an external voltage AC or DC is applied across its control terminal. It serves the same function as the electromechanical relay but has no moving part and therefore results in a larger operational lifetime. SSR consists of sensor which responds to the appropriate input control signal, a solid-state electronic switching device which may switches power to the load circuitry, and coupling mechanism to enable the control signal to activate this switch without mechanical part. The relay may be designed to switch either AC or DC load. Solid-state relay is used to switch either AC or DC. There is no moving part, otherwise it is same function as a electromechanical relay. Okay, packaged solid-state relay are use power semiconductor device such as packaged solid relay use power semiconductor device such as thyristors and transistors to which current up to around 100 amperes. Solid-state relay have fast switching speed compared with electromechanical relays and have no physical contact to wear out. Users of solid-state relay must take into consideration an SSR inability to withstand a large momentary overload the way of mechanical electromechanical relay can as well as either higher on resistance. Okay, operation of solid state relay based on the single Mosfet. Okay, multiple Mosfets in a parallel array can work well for DC loads. MOSFET have an inherent substrate diode that conducts in an inverse direction, so the single MOSFET cannot block current in both directions. For AC bidirectional operation, two MOSFETs are arranged back to back with their source pin tied together. Their drain pins are connected to other side of the output. The substrate diode are alternately reverse biased to block current when the relay is off. When the relay is on, the common source is always riding on an instantaneous signal level, and both gates are biased positive relative to the source by the photodiode. It is common to provide access to the common source so that multiple MOSFETs can be wired in parallel if switching a DC load. Usually a network is provided to speed the turn of the MOSFET when the control input is removed. In AC circuit, SCR or triac relays inherently switch off at the point of zero load current. The circuit will never be interrupted in the middle of the sine wave peak, preventing the large transient voltage that will otherwise occur due to sudden collapse of the magnetic field around the inductor. With the addition of zero-point detectors, the individual SCRs can be switched back on at the start of the new wave. This feature is called zero crossover switching. Okay, parameter switch consider are SSR are characterized by the number of parameters including the required activating input voltage, current, output voltage and current. Where it is AC or DC, voltage drop or resistance affecting output current. Thermal resistance is there. Thermal and electrical parameters for safe operating area. Example is derating according to thermal resistance when repeatedly switching large current. SSR can also include zero crossing hardware to only turn the voltage or on or off when the AC voltage is at zero. Proportional SSR can delay the onset of voltage after the zero crossing in order to lower the current output phase single control. Clear? Advantage and disadvantage is most of the relative advantages of solid state relay over electromechanical relay are common to all solid state devices with when compared to electromechanical devices. Okay, inherently smaller in size. Okay, switch faster than electromechanical relay. Okay, increase lifetime, output resistance constant. Huh? Bounceless operation is there, no sparking in solid state relays. Okay, less sensitive to storage and operating environment. These are the advantage and disadvantage is isolated by supply required gate change circuit is required. Possibility of spacious switching due to voltage transition. Okay, higher transient reserve recovery time is there. These are the disadvantage of this one. These in this unit, in this in this point in relay, we studied what is relay, what are the different types of relay, what is the function, their working principle is there, characteristics are there, advantages is there, and disadvantages are there, applications are there. This is all about relay. Thank you for today's lecture.